I think we'll start with the session. Most of the participants have joined. Good morning, everybody. Dear authors and invited guests, welcome to the technical session 7E. On the behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you to the ninth International Conference on Information and Communication Technology for Competitive Strategies, ICTCS. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held in Jaipur yesterday, the day before yesterday, and the physical event is being held via Zoom meeting yesterday and today, 20th and 21st December. I hope you all will enjoy this session. In this session, in total, we will be having 10 presentations, and each presenter will be given a time span of 10 minutes each. And out of those 10 minutes, 8 minutes will be given for the presentation and 2 for the question and answers. After 7 minutes, I will be raising a gentle reminder. So, this is a kind request to all the participants to please consider the time constraint. Also, there is another request to all the participants that you stay connected with us till the closing remarks. And if you have any query or issues, you can write it to me in the chat box. Now, just before we start the session, I would like to introduce you all to Dr. Parth Shah, today's session chair. Dr. Parth Shah is currently working as a professor and head of Department of Information and Technology, Charusat, Gujarat. His research interests include information security, computer architecture, and cloud computing. Welcome, sir. Thank you for chairing today's session.
Yeah, thank you.
Now we'll go on to the first presenter of today's session. You all can see my screen, right? So the very first presenter we have here today is Sarabjit Kaur, and the paper title she's presenting on is Analysis of Optimization Algorithms to Reduce Energy Consumption in Wireless Sensor Networks.
Good morning to all. Good morning, sir.
Good morning, ma'am.
Um, I have sent you a request to share the screen kindly. Allow.
Yes, I'll stop sharing my screen, then you'll be able to share yours. Ma'am, you can try now. You'll be able to share your screen now.
Okay. Mhm. Just a second.
Yes.
Yes. My screen is visible. Hello.
Yes, it's visible.
Okay, thanks. Good morning to all. My topic is today for analysis of optimization algorithm to reduce energy consumption in wireless sensor network. First of all, what is a wireless sensor network?
Will you
Wireless,
able to present in a full screen mode?
yeah, sure.
Vision mode? Yeah.
Yeah, sure. Sorry. Mhm. Okay. Sir, it is visible now on full screen?
No,
Yes,
again.
ma'am, it is visible.
Okay. Now, first of all, is what is a wireless sensor network? Wireless sensor network composed of sensor nodes deployed to monitor a physical parameter and transmit data wirelessly. For example, smart homes, healthcare, industrial area, and monitoring environment, etc. Next, what is an energy efficiency? Simply means using less energy to perform the same task, that is eliminating energy waste. In other words, we can say that it is a method to reduce energy consumption by using less energy to obtain the same amount of useful output. Now, what are the importance of energy efficiency? Sensor nodes are often deployed in remote location with limited energy sources. So, optimizing energy used is crucial for these their longevity and the effectiveness. Limited battery power, so energy consumption must be optimized for a long-term operations. Wireless communication consume a significant of amount of energy. So we use this in using optimization techniques. Now, what is an IoT? IoT is the Internet of Things. It is a combination of sorry, a network of a physical object like device, building, vehicles, and other item embedded with the electronic.
I guess your full screen presentation is not shared properly.
Just a second, sir. It,
Currently, I am on a slide of what is an energy efficiency. Slide number 3.
Slide number 3. What is an energy efficiency, sir? Now
Yeah,
it is visible?
no, not yet.
Not yet. Just a second. I can share my screen again, sir. Um, Here it is. Just a second, sir.
Yes, no problem.
Now it is visible, sir.
Screen is visible, but it is not in a full screen presentation mode.
Now
Ma'am, I think you should click on the slideshow button, so it
I have
will.
put it in the slideshows, ma'am. मैंने slideshow on
Share
किया
the
हुआ है.
entire screen. Please share the entire screen.
Sorry?
Share the entire screen.
Yes, sir. I have shown the entire screen like this one. But I don't know
Okay, no
how
problem. Go
it
ahead.
is not visible there. But I have put on a full screen.
Okay, no problem. Go ahead.
Okay. Okay. Now, what is an IoT? IoT, a network of physical object, devices, buildings, vehicles, and other items that are embedded with the electronic software, sensor, and network that help to connecting the data, and we can collect and exchange the data between them. Think in internet means a person with heart monitor, water purifier, air conditioner, etc. IoT is a combination of three things, that is sensor, connectivity, and people. Senses that sense the information surrounding from us. Connectivity means we connect using Wi-Fi, GPRS, and pupils and process mean that the collected data need to be processed and that help to convert in a meaningful information. Now, these are some example of Internet of Things like the security cameras, tabs, buildings, mobile phone, purse, heart monitor, and cars also. Next is this data aggregation and its techniques help to collect the data using different techniques. What is then data aggregation? Data aggregation is the approach through which data is collecting from the sensor node and send it to the transmit to the sync nodes. Data aggregation also the process used to avoid redundancy and the save resources. It increase lifetime of overall lifeline of network. Using shortcut path algorithm, nearest node is reached. There are main three techniques in data aggregation. First is centralized approach. Second one is tree-based approach and cluster-based approach. Third one is, and then in centralized approach, in this method, each sensor node selected the most powerful head among the its neighbor and send data packets via the
If
shortest
you are on the
possible path.
fourth, ma'am, you are on the fourth slide, but I am able to see right now. I'm seeing only second slide.
Maybe, sir, it is a network issue, but I have on my screen, I have seen my current screen.
Session coordinator, please check.
Uh, Ma'am, if there's some issue with the PPT, could you just send it to me in the chat box? I'll share on your behalf.
Sure.
This is
Just,
a glitch that happens actually. It happens a lot of times.
yes,
Uh,
I understand. I will share
Yes.
you PPT on the chat box.
Sir, are you able to see the screen now? The full screen? Hello.
Yes, I am.
Um,
Okay, I just want to confirm one thing. Now I'm changing the slides. Are you able to see the slides change?
Yes.
Okay. Ma'am, you can continue where you left. Which slide do you want me to be on right now?
can I change the slides? No, you can change slide now because you have shared
Ma'am,
it.
actually, yes. You just tell me. Yes.
Okay, I am on the next slide.
Just tell
Slide.
me which slide.
Data aggregation
Data
and
aggregation.
Hanji is next
Its
slide.
techniques.
And it's you can
Oh, the next slide.
yes,
This
this one.
centralized approach.
Yes, this one.
Okay.
Okay, ma'am. Just a second. Okay, now I have tell about the data aggregation techniques. Now, first one is a centralized approach. In this method, each sensory node selects the most powerful head node among the neighbors and send the data packets via the shortest possible path. In tree-based approach, tree is formed first known as a DAT, that is data aggregation tree. For each transmission, minimum spanning tree is created. So can data transfer through that. The next one is cluster-based approach. It is the most efficient approach in network ID, divided into a clusters containing various nodes in the cluster. In each cluster, one node selected as a cluster head. That cluster head performs the aggregation and the redundancy. Next slide, please. Now, what is in a cluster-based approach? Benefits and comparison. The data collective the cluster head is created in at individual level whose selection process depend on the parameters such as distance, delay, energy, load, and temperature of the IoT devices. Due to which energy efficiency of the model increase. In tree-based approach, a small change in the data can be a large change in the structure of the decision tree causing instability. In centralized approach, it suffer from the problem of high traffic towards central node due to the large number of messages being transmitted, which reduce the energy efficiency and increase the load on the header node. Next, next slide, please. There are some literature review that have applied on my paper. First paper is a SOTA optimization based on a fuzzy logic algorithm for energy efficiency in wireless sensor network in 2020. In this paper, the purpose, a novel energy efficiency approach for the wireless sensor network uses SOTA optimization algorithm enhanced with a fuzzy logic. It aims to improve energy efficiency in wireless network by optimizing the network parameter based on the fuzzy rule. The outcome of this paper is the proposed approach demonstrates significant improvement in the energy efficiency, prolonging network lifetime, and optimizing resourcing using compared to a traditional method. In the same way, in the second paper, that is chicken swarm optimization based clustering algorithm, this algorithm also helps in shows that the life it improves the network life time and the stable scalability and providing to an efficient optimization technique for wireless sensor network. Next slide, please. Another review paper is the energy efficiency clustering and routing algorithm using ant line optimization in wireless sensor in 2023. In this paper, also working on the ant line optimization that helps to save the energy or improve the energy for the network life span. Next is the EEM and CRP energy efficiency meta heuristic cluster based routing protocol in wireless sensor network in 2023. In this paper, this protocol helps in used in wireless sensor network to improve the energy efficiency in wireless sensor network. Next slide, please. Next slide, please. Next is a novel clustering strategy based sync path optimization for wireless sensor network in 2022. In this paper, novel clustering strategy of optimizing the sync path in the network sensor network. This approach to reduce the energy consumption and improve data transmission efficiency. On next is a short is reptile research, search algorithm for energy consumption optimization in wireless sensor network that is also helping to improve the energy and all over network performance. Next slide, please. Next is develop, sorry, and optimal energy efficiency routing protocol in the wireless network using adaptive entropy, Bell angle search optimization and density based adaptive soft clustering in 2024. In this paper, energy efficient routing strategy for wireless sensor network by combining adaptive and entropy ballad and search optimization to help to improve the energy efficiency and its life span. Next is energy optimization routing for hierarchical clustering based wireless sensor network using artificial bee cloning. In 2023, the purpose sorry, this paper proposed an energy optimization routing protocol for hierarchical cluster based wireless sensor network using the artificial bee cloning. It also helps to improve the lifespan of the network and improve the network lifespan. Next slide, please.
Ma'am, sorry for the interruption, but we are past the presentation time. Could you please conclude it within a minute?
Yeah, sure. In this paper, we have search on a multiple algorithm or methods that help us to show the energy efficiency, how we can improve the energy efficiency or lifespan using these algorithms. Our main purpose of this paper is to choose a proper optimal technique, optimization technique that helps us to save the energy for of our networks. Thank you.
Okay, so can you elaborate on that the PDR was more than 100%? How that is possible?
Then can you repeat your question?
PDR was, you mentioned that more than 100% in the third last slide.
When we conclude these parameters on the simulating, that helps us to not more than but near about 100.
But it was 190% somewhere. How it is possible?
It's depend on the sensing nodes or techniques, and the area depends on it.
Okay.
Thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next presenter of today's session is Rushikesh Patil from SCTR's Pune Institute of Computer Technology, India. And the paper title is Automated Security Testing Using CI/CD Pipeline. So I request any of the authors or co-authors, if you're present in the meet, please start with your presentation.
Yes, ma'am. I'm audible.
Yes, sir, you're audible. I'll stop sharing my screen, then you may start.
Yes, ma'am. Uh, I'm visible.
Yes, your screen is visible. And there's also one more request to the participants. While presenting, it is a request if you could just turn on your cameras as well.
Okay, ma'am. Can I start?
Yes.
So,
But can you turn on your camera as well?
okay, ma'am. Yes, I'll try.
Okay.
Is it visible, ma'am?
Yes.
So, good morning, everyone. Thank you for joining my presentation as my topic is automated security testing in ci pipelines. So, in today's world, as we know that software development is the ensure software development is a very important step in like we are developing websites, but there is also security is one more concern. So to mitigate that or to prevent that, there is a also security testing is important. So let's start with the first slide. So what is CI/CD? So basically, CI/CD stands for continuous integration and continuous deployment. So it is basically a development practice where developers integrate their code changes frequently and automate the development process so that it deploy fastly. So it ensures the faster delivery for more reliable softwares. So what are importance of that pipelines? So first one is that rapid integration and deployment can into so what happens when we try to integrate and deployment. So some what the vulnerabilities can introduce in that website. Also therefore the security is also one more important concern. So these are some common attacks on the CI/CD pipelines. So first one is the supply chain attacks. Supply chain attacks. So where the attackers can insert malicious code in our what do we say repositories. After that, there are multiple like code injection, also that credential theft is also apart. So relevance. So next one is the what we are doing. So we are testing some three. These are three tests. These are we are testing automatically. First one is the static application security testing, and we are using SonarCube as a tool to test this. So first one is so what SST do? So it examines the source code of the source codes and checking the vulnerability before the deployment. So before the deployment, second one is the DAST dynamic application security testing. So these test our website in the running mode like after deployment and scans the vulnerability. Third one is the VAPT vulnerability assessment and penetration testing. So these tests checks the like entire pipeline weaknesses. So checks that where is the pipeline weakness or not. So this is how the integration in CI/CD checking. So what happens? Jenkins is the platform where we are making the creating the pipeline. So first one when the code commit the Jenkins automatically triggers that code is committed. After that automatically SST scans like it is before deployment. After that the build of the our repository created, and after it deployed in a Docker platform, and after that DST scan, and thereafter VAPT scan. So what are the benefits? So there are multiple benefits like we can continuous monitor our pipeline what will happen or that. After that early detection is also one of the major concern that we can reduces our cost and fixing issues. Third one is the efficiency, so we can increase our efficiency. So this is all our workflow, how it will how it will like code commit pipeline trigger. After that SST build, and deployment, DST, VAPT, and after that, at the end, uh, like a report of all these tests is generated, like what is issue and all that, and this will happen. So thank you everyone.
Thank you, sir, for your presentation. Are there any questions?
No, I don't have.
Okay, sir. Then I'll proceed to the next presenter. So the next presenter is VP Jaya Chitra from Anna University, India. And the paper title is A Hybrid Feature Selection Model for Early Heart Attack Prediction Using IOMT Devices. Uh, Ma'am, you're there in the meeting, right? VP Jaya Chitra.
Yeah, I am in the meeting. So we'll share the PPT. Yeah, testing, are you
Yes.
there?
Yes, you are audible, ma'am. You can share your
Yes.
screen now.
Okay. Good morning, one and all present here. Yeah, am I audible? Shall I continue?
Yes, yes, ma'am. You're audible. We can see your
Yes,
screen. You can continue.
yes, ma'am. So good morning, one and all present here. Myself, Jai Chitra, and my authors Tasneem Fatima, Harshavardhini are here to present the paperwork on a hybrid feature selection model for early heart attack prediction using IOMT devices. Next slide. Next slide. So heart diseases remains one of the leading causes for death worldwide. Early detection and timely intervention of heart attack are crucial to improve survival rates. Though traditional methods are proven valuable but often rely on symptoms to appear. With the advancement of technology, IOMP devices have the potential to monitor the individual in real time and gather crucial health parameters, opening up exciting possibilities for early diagnosis and interventions. But these IoT devices faces some major challenges, and these are listed out here. So one is in latency issues. It means that there is a delay in deploying the data and transmission of the data to the cloud server. So another challenges is that data sensitivity issues means that we need to ensure to protect the user's data in secured way. Another challenge is nothing but the dependency on internet connectivity. These IoMT devices are dependent on the internet connectivity, but there are certain cases like in remote areas, we don't have this internet connectivity and there is a network failure. This will disturb the real-time monitoring of the patients. So another major challenge is that IoT devices have limited processing power, memory, and energy resources. Hence, it's very difficult to deploy and high computational ML models on these lightweight IoT devices. So another, moreover, there is the existing lightweight models often fail with less accuracy and less recall, thus making it unsuitable for emergency cases like heart attack predictions. Next slide. So to overcome all these challenges, our research work has listed out the objectives as the solutions for such challenges. The first solution is that uh, how to mitigate this internet access is that we aim to deploy the machine learning model on the edge devices, that is the IOMT device itself. Another aspect is that in order to improve the recall and to avoid the false negatives in case of the heart attack predictions, we use hybrid feature selection model, which will intelligently select the most relevant features. By that, we improve the recall. Another case is that the latency can be minimized and the responsiveness can be enhanced with the help of the edge deployment. That is nothing but IOMT devices. And then to have a lightweight model or to develop a lightweight model which is more suitable for edge devices, we use a tree-based classifiers, which is lightweight in the aspects of computational aspects, and it is also interpretable model. So all these challenges have been overcome by the solutions. Next slide. And here is our architecture diagram, which project our research proposed works. We began with the data collections. All the biomedical markers are collected from the data sets. And the next, we began with the pre-processing phase, which is a basic pre-processing phase. Another is an advanced pre-processing phase. In order to enhance the accuracy of the model, we do the basic pre-processing like missing values, and then normalizations and outlier removal to enhance the data quality of the data set. We use the SMART and FCBC pre-processing technique. After pre-processing techniques, we go ahead with the optimization techniques. Here we use the hybrid optimization techniques. So one is an ant colony optimizations to select the most relevant features which is suitable for heart attack predictions. Another is a genetic algorithm which will tune the hyperparameters such that we can enhance the efficiency of the training model. So after optimization process, these optimized parameters and the most relevant features are given to the chosen training model, which is nothing but tree classifier. So here we use extra tree classifier and compared with the existing random forest and XBoost algorithm. The trained model is then deployed in the edge devices with the help of the lightweight interface called Tinter. Once the deployment is done, the model is evaluated based on 5 level classifications. One is normal, mild, moderate heart attack, and then severe heart attack and critical heart attack. So this is regarding our architecture of the proposed work. Next slide. So this and all the steps of the proposed methodology. Here we use the biomedical markers like blood pressure, cholesterol, sugar level, resting ECG, heartbeat, depression, and thalassemia. So this and all used for that. And we use the smooth technology, which is nothing but synthetic minority oversampling technique. So which is used for balancing the class. Another aspect is nothing but FCBC, fast correlation based filter feature selection method is used to select the most correlated features. Then the another optimization technique called ACOE optimization techniques is used to select the optimal features that will enhance the recall of our prediction model. Next slide. So then the tree-based classifiers like extra tree, random forest, XGBoost models are used to test our training data set. And the best model with high accuracy and recall was chosen, which is nothing but the extra tree classifier. Then the model is deployed the edge devices, uh, and we tested it for the basic given users data, real-time data. Next. Yeah, next I request Tasneem to proceed.
Ma'am, sorry for the interruption, but we are past the presentation time. So
Okay,
could you please conclude it?
yes, next we go for slides. Tasneem, you just go ahead with the conclusion of the results. Okay, here you can, yeah, comparison with the latency of edge versus the cloud. You can proceed.
Yeah, this is the performance analysis of our three tree-based classifiers. So here you can see that extra tree gives the best accuracy and recall for critical classes. And for edge versus cloud, we could see improvement in the latency. And these are the tune hyperparameters. So here, number of estimators, which means the number of trees has got reduced. So the memory requirements also get balanced, and the latency is also compared. So before our future selection, these are our classification report. When we use our hybrid future selection, we could see improvement in accuracy and overall all the performance metrics compared to use not using the hybrid future selection. So this is sir, and we compared our proposed work with the previous work too. We could see accuracy improvement as well as other metrics, recall, precision, and F1 score improvement through our proposed work.
So overall, we handled imbalanced classes and misclassifications, and we reduced our variance using our proposed hybrid feature selection and oversampling technique. And we balanced the accuracy as well as the memory requirement, so that making it suitable for edge deployment as well as to uh, make the best prediction, since it is a critical scenario like heart disease prediction. And we prevent misclassifications like false negatives by improvement in recall, so that a person having a heart attack will not be predicted as not having heart attack. And through our proposed work, we can also predict future anomalies too. Since our target class is multi class, like normal, mild, moderate, severe, and critical, we can get predict even future possibilities of experiencing heart attacks. So these are our references. Thank you.
Thank you, ma'am, for the presentation. Sir, are there any questions?
Yeah. What is the size of data set, training and testing both?
Yeah. Tasneem,
Can you please repeat the question?
What is the size of data set in the case of training as well as testing both?
We have totally about 700 rows, and it is a CSV type data set. So we use 20% for testing and remaining 80% for training.
And from where did you get this data?
From UCI machine learning repository.
Okay. Okay.
Okay, thank you, ma'am. Thank you, sir. Now we'll proceed to the next presenter.
thank you.
So the next presenter is Junaid Mullah sir from Vishwakarma Institute of Information Technology. And the paper title is Enhancing Adaptive Learning with Deep Learning Models, a comparative study of ANN and LSTM approaches. Junaid sir, you're there in the meeting, right? So I'll stop sharing my screen and you may start with your presentation.
Yes.
And there is a request if you could just turn on your camera while presenting.
Hello, is my screen visible?
Yes, sir, your screen is visible.
Okay. Okay. So, good morning, everyone. My name is Junaid, and today I'll be presenting the topic enhancing adaptive learning with deep learning models, which is a comparative study of ANN and LSTM approaches. These are the authors, and yeah, so the flow of the presentation will be I'll first explain the introduction, abstract, motivation, then the method, then the results, and the conclusion. So introduction, basically, now education is undergoing a significant transformation. So just a moment. Yeah. Okay. Yeah. So uh, basically, earlier education was very traditional. Like it was not uh, catered to the personal needs of every person. So now there is we due to machine learning and deep learning, we can make it possible that the education can be catered to the individual needs, and so this way we have an adaptive testing system which basically dynamically adjusts the question difficulty in real time based on the individual responses received uh, according to the learner's pace, understanding, and like the answering patterns of each of the questions. So we have used deep learning models for this. And okay, so basically, as I mentioned, we are using deep learning models, and earlier research showed that machine learning models have also been used for this purpose, like logistic regression and random forest, which achieved good accuracies from 66% to 92%. But these were with high amounts of variance, and there was poor generalization across datasets. Despite high accuracy, these models lacked reliability. So to address this, we have used AI, like artificial neural networks, and RNNs in particular, because they are well known for their reliability in time-dependent datasets. And so in RNN, we have particularly focused on biLSTMs because they have the ability to focus on the past and the future data to predict the current data. So results have revealed that biLSTM models achieve a considerable 85% accuracy. Not Although they don't outperform the highest accuracy of the normal machine learning models, logistic regression and random forest, but they are more reliable, and they provide repeatability of results and generalize well on other data sets. Uh, so the motivation was driven by that uh, like stud it, traditional education often struggles to meet individual students' needs, so which limits the pace with which each student can learn. For example, the students who have slower understanding need a slower pace, and who the students who have a who catch on earlier are often bored by the slow pace if a teacher is like go, teaching with a slow pace. So in this way, we need personalized learning solutions. So even this is the case while testing. So when we test students, so test same testing students on the same question set is like we are not able to assess their strengths in each of the individual topics. So personalized testing helps identify their individual strengths and weaknesses and their understanding of concepts in different topics. um, yep. And the method used was basically we first prepared a synthetic data set. There was then data pre-processing, the train test split, the general 80 to 20 validation and training and validation split, and then the model fit, which was on the two data sets, simple ANNs and biLSTMs, and then the prediction and model evaluation. So the synthetic data generation basically was the columns for these were determined on the basis of the generic structure of any test. So there is difficulty of the questions. There are several subjects we have chosen: physics, chemistry, maths, the year asked, and the answer key. And then based on the difficulty, we had further included columns. While we had further included columns of time taken and number of attempts. And based on the difficulty, these were accordingly, like the time taken would be greater for difficult questions, and the number of attempts would taken to solve the question, solve a particular question, would also be greater for a higher, more difficult question. So these were in proportion with the difficulty. So the models trained were simple ANN and bidirectional LSTM, as I mentioned. The architecture of the simple ANN was two dense layers, which basically used a Rayleigh activation function because it performed well on these. And the last layer used a softmax activation, which was used for because we are finally categorizing each question as based on the past data. We are categorizing each question as solvable or unsolvable. So we have used softmax for this categorical classification. The ANN model was trained for 10 epochs because after that it successfully converged and there was a consistent performance. Then in case of the architecture of the biLSTM, there was a first bidirectional layer, and then there was a dense layer, and there was the final softmax classification layer. The middle dense layer once again employed a similar Rayleigh activation function, and this also helps us like compare between the two models, ANN and the biLSTM, because we have employed similar activation functions in them. And LSTM also used a dropout with rate of 0.2. This model was trained for 15 epochs. The reason for this was because the it had to because of the complexity of the model, it took a bit more number of epochs for convergence. So it required 15 epochs.
So,
Um,
sorry
yeah.
for the interruption, but we are past the presentation time now.
Okay. Okay, I'll just conclude.
Yes.
So both the models were used the Adam optimizer and sparse categorical cross entropy, and we have used exponential decay learning because the learning rate eventually decreases. So the model explores the possible solutions and then finally expands on the potential good solutions. So model evaluation, we have used accuracy versus epoch graphs and confusion matrices, and also the bar graphs for comparison of various metrics. So the results of the simple NN model are this, where it achieved training accuracy of 80 and validation of accuracy of about 79%. And the BiLSTM model was this. The training accuracy was 85 and validation accuracy was also very similar, 85.94. As we can see, it generalizes well. And in the computer confusion matrices, we can see that the NN model has lesser false negatives and false positives, uh, uh, which is a good thing. And BiLSTM model like outperforms it even further, and there are no false negatives, and there are only false positives. So this can also be seen here. It performs very well on the recall metric. Yeah, so it gives a recall of 1 because there are no false negatives, and these are the summary of the results. So conclusion, we can say that BiLSTMs, due to their internal memory and ability to handle time dependent data, are better at handling the such kind of data, and ANNs are in general better identifying patterns and among data, and they can generalize better. So, and further enhancements will include more advanced deep learning models and transfer learning, and further refined data pre-processing and techniques like data augmentation and so on. Thank you.
Thank you, sir. Are there any questions?
Yeah, in place of using the synthetic data, you could have used the real data. So does that mean that you didn't get that kind of data?
Yes, sir. It was difficult to find like the data because there was like it's generally private and access is restricted. So we had to do with the synthetic data.
Okay.
Okay, then we'll proceed to the next presenter.
Okay, thank you.
Thank you, sir. So the next presenter is Gargi Nitin Rangnekar from DY Patil Institute of Technology, India. And the paper title is Review on Predicting Space Weather Impacts Using Machine Learning Techniques for Aviation and Telecommunications. Gargi ma'am, you're there in the meeting.
Hi, yes, I'm in the meeting.
Okay, you can start with your presentation.
Okay, sure. Give me 1 second.
Okay, just consider the time constraint of 7 minutes, then I'll raise a reminder.
Yeah, sure.
Thank you.
Hello. Can I start?
Yes.
Okay. Good morning, everyone. And my paper is based on a review on predicting space weather impacts using machine learning techniques for aviation and telecommunication. So, the major focus here is on studying and understanding the space weather impacts that occur and that disrupt various sectors. We are focusing on aviation telecommunication because these are the most affected sectors. My authors are myself, my peers Gayatri, Adarsh, and my professor Manisha Manima. So I'll start with giving you an introduction of how which things affect the space weather's impact. Starting with solar flares. Solar flares are sudden bursts of energy from the sun's surface that can release radiation and which can reach the Earth in minutes. Because as we know, light reaches in seconds. So anything that is particular that will disrupt the Earth's atmosphere, this can affect the aviation and telecommunication industries. The second part is the coronal mass ejections, which are giant clouds of magnetized plasma that erupt from the sun's corona. Then you have the geomagnetic storms, which are the disruptions in the Earth's magnetic field, again caused due to the coronal mass ejections. Then you have ionospheric disturbances, which are the short-term variations from the normal state of the ionosphere, the one that we have above the stratosphere, that can be caused due to the solar activity. Then you have the interplanetary magnetic field, which is surrounding the entire Earth, which the magnetic field carried by the solar wind as it flows from the sun. So this field can interact with the a magnetic field that we have around the Earth, and it will affect and change stuff. Then you have the solar energy particles, which are carried by the solar flares, which are high energy particles, and primarily they are protons and electrons. And these can also cause disturbances and auroral data, which kind of are a good thing, but not just for not. I mean, they're a good thing because we like to look at them, but they're not really healthy when it comes to the sectors that we're mentioning. Uh, Moving forward, just one second. So our statement is about the space weather risk. So how it is gonna affect the space weather, which these solar flares can cause radio blackouts and majorly satellite malfunctions. I mean, we know that there are almost like thousands and thousands of satellites that are surrounding the Earth's atmosphere. So if a very giant solar flare or any kind of solar activity occurs, it will definitely cause solar blackouts and satellite malfunctions. These are the case studies that we studied when we started studying for this project, which date back from 1972 up until January 2023, like you can see. So there were a lot of small and big solar events that caused a lot of disruptions. Like you can see, in 1972, it disrupted the U.S. Navy's anti-ship minefield near Vietnam, leading to accidental detonations. Some airlines faced challenges. Had to reroute their flights. The pilots experienced radio blackouts and polar routes, leading to flight reroutings and delays. So these kinds of stuff are the ones that we actually don't study or don't understand really, which is why we thought of going into this particular sector. So our dashboard objective is, we will first of all, there's not enough situational awareness about this topic because it's a very new thing. And with the growing amount of space study and space weather things that we do, sending out satellites, this is a very crucial aspect that we should study so as to understand how to place our satellites in the correct locations, or how to plan the air flight journeys and stuff. So our dashboard objective is to enhance the situation awareness. It will also be predicting. We will be using machine learning models to predict the solar events and all the activities that is occurring in real time, and risk mitigation. So the requirement for developing this dashboard was, we had to study three types of things, which was the aviation operators, the satellite operators, and the power grid operators, which will give us solar real time data on the solar flares and CMEs, radiation levels, and geomagnetic storms. These are the development steps.
All right. So, as you can see, there are a total of 12 development steps, starting with defining the requirements and objectives, which is something that we've already done. Understanding the impacts of space weather, which was already mentioned, the radio blackouts and the satellite malfunctions that can happen. Planning the dashboard architecture, and acquiring the process and data, basically the real-time data that we will be getting from sources, which we will be implementing, as you can see, in the predictive models in order to forecast and predict the space weather disruptions that can be happening. Designing the user interface and basically expanding the user experience,
because space weather is one sector in which people cannot understand what's going on right away. Therefore, we aim to make the user interface very easy and very interactive as well. And we'll be doing that by developing the front end using the Unreal Engine 5, which is basically a visually compelling tool where we can basically implement the variations of the planets and the solar flares exhibiting by the sun and how it affects the Earth. Development of the backend as well as testing and validating of the entire dashboard is also something that we will be performing in order to basically enhance the user experience that the our customers and the audiences will be facing. Going ahead with deployment of the dashboard, monitoring and maintaining the dashboard, and obviously planning for future enhancements, something that we aim to do is to implement alerts into the dashboard so that in case there are any space weather disruptions that could be happening, then the users will be able to get alerts for the same with the dashboard. Talking a little more about the dashboard architecture, there would be the front end, back end, and obviously the database. Front end would be established, as I mentioned before, using the Unreal Engine, which is basically used for real time 3D visualizations of auroral data, solar winds, and other space phenomena. Talking about the backend, as you can see, the data sources, we will be getting real-time data from inputs of NOAA's, which basically is a space weather agency that provides real-time data specifically for projects that have been circulated around this. Data processing, as I mentioned, as my friend mentioned, handles the solar X-ray flux, the auroral data, and the disruptions that will basically be affecting the aviations and the telecommunication industries. And the major database.
Sorry for interruption, ma'am, but we the presentation
Ma'am, you're
concluded.
cracking up a little. Can you repeat that?
Hello?
Yeah,
Hello?
okay.
I just wanted to say, could you conclude it because we are past the presentation time?
Yes, okay. These are basically just the machine learning and deep learning strategies that we will be applying. This includes the convolutional neural networks, the recurrent neural networks. We specifically chose this one because we will be using real-time data, random forest, SVMs, as well as gradient boosting algorithms. All of these would be implemented in the predictive models, which will predict and forecast the data. This is the overall architecture. I will not go into the specifications of it right now, but this is basically what our flowchart of the architecture would look like. This is just one of the video presentations of exactly how the space weather visualization will look like using the Unreal Engine, as I have mentioned. And finally, these are the intellectual property rights that we have applied for, and our project did get selected into that as well. So yeah, that is the conclusion. Thank you so much.
Good work.
Thank you so much.
Thank you so much.
Thank you, ma'am, for your presentation. Now, should I proceed further?
Yes, please.
So the next presenter is Pulak Islam from East West University, Bangladesh. And the paper title is Rose Disease Detection Using YOLO, a deep learning based approach. Pulak sir, you're there in the meeting. You can start with your presentation.
Yes, ma'am. I'm starting. Okay.
Uh,
Just give me 1 minute, ma'am.
okay, sir. Hello? Am I audible? Hello?
No, ma'am, can you hear me?
Yes. Can you start with your presentation now?
Yes, ma'am, I am starting my presentation.
Okay.
Good morning, everyone. It's an honor to stand before you today, the 19th International Conference on Information and Communication Technology, to present our research titled Rose Digitation using Uloviate a deep learning-based approach. My name is Zinedine Zidane, and I am delighted to share my findings, innovation in this domain. Rose farming is crucial for sector for the ornamental purposes, but also for economic significance globally. However, it faces persistent challenges, diseases, and severely impact crop yield and quality. Farmers often struggle with timely detection and effective treatment of these diseases due to the labor-intensive and time-consuming nature and traditional methods. This gap motivates our research as we sought to develop a solution that combines the power and artificial intelligence with practical farming. Our primary goal was to create a system that enables farmers to detect rose disease accurately and efficiently in real time. Also, aim to provide a platform where users can access plantation guidelines and disease diagnosis recommendations, including information on pesticides and e-commerce links for purchasing them. Ultimately, we envision a solution to work seamlessly on both web and mobile applications, integrating deep learning models to modernize farming practices. In our exploration existing literature, we found that several models, including CNN and earlier version of Yulu, have been employed to plan this detection, where the approaches were so promised they were often constrained by scalability issues and real-time applicationability. This realization underscores the need for more robust, accurate, and user-friendly approach, one that bridges the gap between laboratory science and real-world farming scenarios. Our proposed methodology is to address this. We have to do a hybrid dataset approach combining raw image collected from rose plants with public laboratory datasets, and we applied advanced image processing technique such as resizing, rotation, and augmentation using TensorFlow to enhance the quality and diversity of data. Multiply model, we trained YOLO V5 and YOLO V8 among the image models for the choice thanks to its advanced architecture for optimized for feature extraction, automatic parameters, uh, selection, and effective handling of limited data through transfer learning. The result of our efforts incredibly promising. Uleviate not only delivered high valuation accuracy but also excelled in real time of the detection from both images and videos. Our system was further enhanced with a web and mobile application providing farmers with disease diagnosis and treatment recommendations. Challenges in future work is our, of course, journey was not without its challenges. Limited access to comprehensive dataset and financial constraint for application development were significantly hurdles. Debugging also proved to be time intensive. However, the challenge we only stranded to resolve, improve the system further. Moving forward, we plan to expand our dataset, experiment with other AI models and the chatbot development for IoT device and real-time disease monitoring, collaborating with AI industries to refine our solutions. In conclusion, these research demonstrates the potential of Uloviate to revolutionize rose disease farming by providing an efficient, accurate, and real-time disease detection system by integrating artificial intelligence into agriculture. And we not only aim to modernize farming practices, but also empower farmers to minimize their losses and maximize productivity. Thank you for your attention. I am happy to address my research. Any question for you may have. Thank you.
Thank you, sir. Are there any questions or should I proceed further?
Next one.
Okay.
Ma'am,
Yes.
I'm sorry for the interruption, ma'am. I want to continue the presentation, but I have net issue, internet issue, so that's why I just give it to my other author. Sorry for the convenience.
Uh, no, it's fine, sir. Actually, any of the co-authors can share the screen or present. It is allowed. So it
Okay,
isn't an
ma'am.
issue.
Thank you for your contribution, ma'am. Thank you.
Thank you, sir. Now I'll proceed further. And the next presenter we have here today is Khushi Rathi from SCTS Pune Institute of Computer Technology, and the paper title is Soil Parameters Detection.
One second.
Yes. It is completely fine if you're not able to present the screen. I can present on your behalf, or any of the co-authors can also present.
Yeah, 1 minute.
Yes.
Can you give permission to Vaishnavi Zadav?
We can see your screen now. You can start with your presentation.
Okay, thank you. Hello, my name is Khushi Rathi. I'm fourth year undergrad student at PICT, pursuing electronics and telecommunication engineering. The title of my paper is Soil Parameter Detection, and my co-authors are Fiza Kushwaha, Vaishnavi Zadav, HB Mali, and Tushar Patil. Next slide. So, the motivation for this paper arises from critical global challenges of soil degradation. Around 40% of Earth's land degraded, impacting 50% of global population, endangering nearly half of the world's GDP. Agriculture, which contributes to 80% of this degradation, is a major factor. A key issue is the lack of awareness among farmers regarding the soil nutrition. Our aim is to tackle this problem by developing a solution to enhance soil health and promote sustainable agriculture practices. What is the difference between the traditional soil testing and our model is that traditional soil testing method are time consuming and often delayed, and our model gives solution in a in within a second. Next slide. This diagram represents the architecture of soil parameter detection system. Here is a detailed explanation. First is salinity block. It measures the soil salinity or electrical conductivity. And the next is NPK sensor. It detects the level of nitrogen, phosphorus, potassium in the soil. Then it is a pH sensor, measures the acidity or alkalinity. Then moisture sensor, it gives the water content in the soil. Third, temperature sensor, captures the soil temperature, which impact plant growth. Then there is a signal conditioning block. This block processes the raw signals from the sensor, converting them into a format that can be read and interpreted by the microcontroller. It ensures data accuracy and removes noise. Then microcontroller. It is a central processing unit of the system. It collects the conditional data from all the sensor and process it. Then there is a GSM module. It facilitates the communication between the system and the remote server. It sends the process sensor data to the server via cellular network. Server stores the transmitted data and provide access to it. This data can be used to analysis, visualization, or providing recommendation to the farmers. Next slide. Um, how our proposed system work? Sensor measure various soil parameters. The data from the sensor is sent to the signal conditioning unit for processing. The conditioner signals are transmitted to the microcontroller for integration and processing. The microcontroller send the process data to GSM module, and the GSM module transmit the data to a server for storage and further analysis. Next slide. So the NPK sensor is based on the fiber optic technology. In that, we are using optic fiber cable, um, and the light. First part is light emission. The LEDs emits light, then light transmission. The light travels through the optic fiber cable to the liquid sample. In this liquid sample, we use the aqueous solution of the soil. Second is light interaction. The light interacts with the liquid and a portion is absorbed and reflected based on the NPK concentration. The light detection. The reflected light is captured by the optic fibers cable and transmitted back to the photodiode. The photodiode converts this light into an electrical signal, and then we do data processing. The electrical signal is processed to determine the NPK concentration. Here we have used the 7 LEDs, red, yellow, green, blue. The purpose behind is that in nitrogen, phosphorus, and potassium is sensitive to different lights. Next. Nitrogen is sensitive to blue light, phosphorus is sensitive to green light, and potassium is sensitive to red light. And we basically process our data using Beer-Lambert's law, where absorbance is equals to log of I naught upon IT, where A is absorbance, which measure how much light is absorbed by the sample. I naught is the intensity of incident light, the light that enters the sample, that is aqueous solution of soil. IT is the intensity of transmitted light, that light that passes through the sample. This equation describes how absorbance is related to the ratio of incident light to transmitted light. And then absorbance is equals to epsilon C L. Epsilon is molar absorbability, C is a concentration, and L is the path length. With the absorbance, we can calculate the concentration of nitrogen, phosphorus, potassium in the soil and recommend the farmer about the specific demand. Next. And the other sensor, we will use the ready-made sensors like salinity sensor, pH sensor, moisture sensor, and temperature sensor. And we propose to develop NPK sensor using fiber optic technology. Next.
Ma'am, sorry for the interruption, but we are past the presentation time now. Could you please conclude?
So we are basically developing a, a technology which measures the nitrogen, phosphorus, potassium concentration, and will recommend the farmer how much nitrogen, phosphorus, potassium should be added in the soil for fertility. Thank you.
Thank you, ma'am, for your presentation. Are there any questions?
No.
Okay, now we'll go on to the next one. So the next participant is Shraddha Asolkar from SCTS Pune Institute of Computer Technology, and the paper title is Resume Screener Using LLMs. Ma'am, can you start with your presentation?
Good morning.
I think
Just give me
Pranjal.
a second.
Okay.
Okay, good morning, everyone. So I will be talking about the first half of the project. Our title is Resume Screener using LLM, and we are from PICT, and group members are Shraddha, Vaishnavi, Pranjal. So our problem statement is the recruitment processes are evolving with an increasing number of online application. A manual resume screening is labor intensive and very time consuming, and high volume and diversity of application make traditional methods a little bit inefficient, and therefore even bias and inconsistency can occur, leading to unfair hiring outcomes. Scalable and automated solution is required to handle these challenges effectively. So the purpose is to develop an AI powered automated resume screening system using LLM and generative AI technology to address the inefficiencies in manual screening by enhancing accuracy and fairness. Scope is automate the passing, evaluation, and ranking of resumes based on role specific criteria such as skills, role specific criteria such as skills, experience, qualification, and also incorporate AI tools like NLP and machine learning algorithms to handle the resume data. Create a scalable system that integrates seamlessly with existing HR platforms. And objectives are to automate the resume screening process using advanced AI techniques, improve the accuracy of matching resumes with job description, and minimize bias and ensure fair candidate evaluation, handle high volumes of application efficiently without compromising quality, provide transparency and consistency in the recruitment process, facilitate easy integration with existing HR software for seamless operation. Abstract is the traditional manual process of resume screening is a bit inefficient, error prone, biased, and our solution that is that AI driven technology should be used, including our proposed solution leverages AI driven technologies, including LLMs and generative AI, to automate and enhance this process by utilizing advanced NLP techniques, machine learning models. The system ensures accurate and unbiased, efficient resume evaluation. Key benefits include reduced manual effort, faster processing times, improved fairness in the recruitment decision. System overview. Okay, so the hardware requirements are as specified, and in software we are using Python, LangChain, Fast API, front end. In front end, we are using React, Axios, Material UI, and databases are Postgre and MongoDB. In system architecture, system workflow, resumes are uploaded via the front-end interface. Resumes are passed using NLP techniques such as named entity recognition to extract relevant details. The LLM performs semantic analysis to understand the context and match candidates to job description. Scores are generated based on alignment with job criteria. Shortlisted candidates are ranked and presented to HR teams for review. Okay, so it works. First, we give the data set and then clean the data, tokenize the data according to the needs of the job description, train the model, and save the trained model, and then build the further models according to the trained model. Okay, software stack. So here first the applicants will input their file, and then the resumes, the data from the resumes will be extracted, and this file data will be saved in a CSV file, and that data will be cleaned, and then there will be vectorization of that data, and according to what data needs to be extracted, the prompt and models will be written, and then the user or the recruiter will input the job description, and then according to the job description, the CSV file which contains the data of the applicants will match the data and see who is a better fit for the job description. Okay, so the further slides are literature survey, which my teammate will continue. Shraddha.
So for the literature survey, our literature survey examines the evaluation of
Ma'am,
automated.
sorry for the interruption, but we are past the presentation time. So can we proceed to the conclusion part?
Here we can see the results as a performance comparison of resume screening methods are described in the three different attributes. Like for example, the blue part is for the traditional methods, and the orange part is for the machine learning, and green is the LLM based. So LLM performance. So this is the accuracy, then precision, and the recall scores and F1, then bias reduction. These were the references we have referred for the overall our paper presentation. So thank you.
Thank you, ma'am, for the presentation. Are there any questions?
No.
Okay, we'll go on to the next one then. So the next presenter is Jacob Jayaraj Golamondi, sir, from DRK Institute of Science and Technology, India. The paper title is Hybrid Deep Learning for Enhanced Brain Tumor Detection, Leveraging LBP and Dual RESTnet 50 Networks. Jacob, sir, you're there in the meeting, or any of the co-authors, if you're present, to present this paper. Anyone in the meeting from their team? If no one is present, then we can move on to the last presenter. I think they have not joined. So we'll go on to the next presenter, who is Ronit Munde from JSPM Rajashri Shahu College of Engineering, India. And the paper title is Survey on Positive X PET Consultation System with IoT and ML Integration. Ronit, sir, you're there in the meeting.
Yes, am I audible?
Yes, you are audible. You may start with your presentation now.
My screen is visible?
Yes, sir, your screen is visible.
Okay. So, good morning, everyone. My name is Ronit Munde, and our project name is PositiveX, a pet consultant system integrated with IoT and machine learning. My co-authors are Vaishnavi Chavan, Shriyata Basme, Saurabh Sabale, and our professor Neeraj Kumar Satavane. So the problem statement is nowadays pet health is often reactive instead of proactive. So we have identified the gap that pet owners often identify the issue related to their pet after the issue is appeared or the symptoms are appeared, which may result in delay in treatment. And it also difficult to veterinarians or location or different locations to provide the treatment to the pet to that particular location. So we have developed this project to avoid this gap. So our key stakeholders are pet owners, veterinarians, and pet welfare organizations. So for this literature survey, we are basically making an application which is mobile application in which we are adding which is integrated with Internet of Things IoT device and machine learning. So right now we have done several literature survey on there were several papers which are related on this topic. So first is dairy cow weight, a mobile expert system for disease diagnosis of dairy cow, in which they have taken the various symptoms and parameters of cows, such as gender, age range, symptom significance, and certainty. And depending upon that, they have diagnosed the cow disease. And this paper is published in 2015. Then we have taken the second paper, which is activity recognition and tracking system for domestic animals. In this paper, they have using simply IoT device to track the stats of the animals and verify that they are sitting, walking, or running on the basis of their IoT collar. In then third paper, the IoT device is used for the pet care system, in which they have used the data. They have extracted the data of pet animals such as heart attack detection and temperature and accelerometer. And in this paper, they have only taken the data and display the data on their application. Along with that, we have also researched some another papers which are related to our topic, such as web-based health monitoring system, in which they have collected the data from IoT sensors and display that statistics or data on a web application. In another paper, they have developed the machine learning model to predict certain disease. We have done research on this machine learning model because we are also predicting the disease on the basis of IoT caller. Then third is deep learning based IoT solution, in which they have done the research, in which they have developed the deep learning model, in which they have predict a disease, or we can say the predict the activity of the pet animal on the basis of the video, which is on the video provided to the model. Then IoT system recognizes to track and daily activities. So this system had developed the IoT sensor, which analyze the daily activities of animals such as sitting, walking, or running, and display on the mobile application. And another is IoT based pet care system, to food dispenser system, food dispenser system for pet animals. So by this research, we have identified the loopholes of every application, and we have developed the solution. So these are the real-time systems which are already in the market and available for the users. We have compared it with different parameters such as location tracking, health monitoring, appointment scheduling, along with positive X and others such as pet pace, feedback, trackative, pet pal, and whistle. We have identified each feature from each existing system and try to provide those features in our application. So, what are the features we are providing in our application, such as real-time health monitoring, predictive analysis, GPS tracking, mobile application, data storage and analysis, user alerts, and customizable insights. So, in real-time health monitoring, we are using different sensors to track the data. In predictive analysis, we are using that data to predict the diseases, and those data are accurate. In GPS tracking, we are providing the accurate location of your pet. So, if you are in office or any other place, you can simply track the pet data. A mobile application to for the user interaction, and we are storing that data so that other veterinarians can use that data or your statistical data for their next treatment. So this is a basic simple architecture diagram of a project in which there are user and doctor, and they can simply communicate with the mobile application, in which we are providing the features such as the diet plan, appointment booking, accessories, exercise plan, disease predictions, and health monitoring and location data. So in predictions, we are using artificial neural network for multi-class classification. Basically, artificial neural network is used for binary prediction, which is 0 or 1, but we are using multi-class classification by adding softmax layer. So this is the IoT circuit diagram which we are using in our device. So we are using ESP32 as a controller board for our application, and along with other sensors. The accuracy is completely dependent on the type and quality of the sensor. So currently I'm using these sensors, and it will be upgraded as per the sensors quality get higher. So in prototype, we are using real-time health monitoring is achieved through using different sensors and IoT device. The predictive health analysis is available by using artificial neural network, and along with sensor data, we are also taking the pet symptoms, then GPS location, mobile integration, battery efficient, 24 ability. So what are the challenges we are facing? The sensor accuracy. The sensor accuracy is always varying on the type of sensor and the quality of sensor, so it can be improved. Battery life is optimized depending the device is compact, so the battery life is around 11 to 12 hours, but it can be increased. Then data privacy, we have to secure the data which we have collected from the pet as well as pet owners. Then stable communication and the model performance, the model should be continuously monitoring and trained for the higher performance. So in conclusion, the positive X system integrates IoT and machine learning to revolutionize pet care by enabling real-time health monitoring and behavior analysis and disease prediction. And it also provides a unified platform for pet owners as well as veterinarians to offering the tailored solution for pet health. So these are some more references we have taken for the research. Thank you.
Thank you, sir, for your presentation. Are there any questions?
No.
Okay, so for the last time, I'm going to announce one more name. Jacob, anyone from the paper title of Jacob, sir, is present in the meeting? Any of the co authors? If not, then we'll have to proceed to the closing remarks. We'll just wait for a half a minute. I think we should proceed. Uh, Now we are at the end of this session, so I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the ninth version and all the previous 8 versions of this conference. We will be happy to have you in the 10th version in 2025. All the presenters would be getting their digital certificates via email within 2 working days, and further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with our team of ICTTCS. I would also like to thank our session chair, Professor Path Shah, for chairing this session. A token of appreciation to the chair on behalf of Team ICT TCS and Global Knowledge Research Foundation. Thank you for your valuable presence. Now, before ending this session, I want to request all of you to please switch on your cameras so that I can take a quick snapshot of today's virtual conference. Just give me a second. Okay, so I've taken the snapshot. Everyone can leave the meet now. Thank you.